Hello world, I made a power bank for an upcoming project. I was inspired by another YouTube video and I have shared a link to it in the description below. There are minor differences in the components I've procured. So all I've used here is a 3.7 volt mobile battery, a lithium charge protection module, as well as a DC to DC 5 volt step up module, and a sliding switch and a plastic case. So what you see on the breadboard here is my upcoming project, hence it's not important for this video. However, I've used a 9 volt battery to power this thing and I learned the hard way that it doesn't last very long, hence the need for a very cheap power bank. As far as the connections are concerned, they're pretty simple. Okay, we have a battery positive terminal for the lithium charge protection module as well as a battery negative. They go into the positive and negative terminals of the 3.7 volt battery. So the lithium charge protection module, or this circuit alone, is responsible for properly charging the battery. The battery itself serves a 3.7 volt output. But for charging anything like a phone or this particular project, it requires 5 volts. So we need a module that actually steps 3.7 volts to 5 volts, and that's where this particular module comes in. It's called a DC-DC step-up module, and it has two terminals called the input positive and the input negative. They are connected to the battery's positive and negative terminals, and I also have installed a switch in between the negative terminals. So that's as far as the connections are concerned. In the particular case here, I have the battery installed and its positive and negatives are actually connected to a breadboard. So I have exposed the terminals there just for the ease of soldering these wires. And I have actually fastened the battery using a styrofoam. So you can see the positive of the lithium charge protection module is connected to the positive, and the negative of the lithium charge module is actually connected to the negative. Now this alone helps with charging the lithium battery. When you plug it in the charger, it glows red, which shows that it's in a charging state, and once the battery has attained full charge, it will grow, the red LED will glow out and a blue LED will start glowing, which means the battery is completely charged. Now when you want to use the output from it, you have to turn on the switch and actually connect a load in the USB female terminal there. So you can easily actually power or charge a phone battery using this. So this gives an output of 5.28, as you can see here. A charger, a phone would actually require something like 5 or 5.2, something like that. So it's a very safe voltage for charging your phones. So let's now connect a phone to it and see how this charges a phone. And you notice the phone is actually in the charging state. If you want to see it better, and it is actually showing 12 volt charging or 12% charging. Now there's something which I missed out mentioning about the step-up module. Its documentation says like it can provide 5.1 or 5.2 volts at some 500 mA. But what we are seeing here is the phone is actually trying to charge at a rate of some 500 mA, but this particular setup is not providing the 500 mAh, hence it is providing probably around something around 380 or 290 mAh, and the voltage drops to 4.5. This is something I noticed with this particular module. It's probably that this module is faulty, or you guys can try this experiment yourself and report any difference that you find. Now let's demonstrate how we charge this particular lithium battery. And you can see it glows red, which means the battery is charging. Once the red LED turns off, the blue LED turns on, which means the battery is completely charged. So that's it, guys. Try to implement the project on your own and share the results. Have a nice day. Thank you.
Now, as I'm uploading this video, I'm aware of the situation in Kerala due to these heavy rains. So my own hometown is facing issues due to waterlogging, and even my own house is waterlogged at the moment. Even the nearby surrounding areas are waterlogged. So I would advise everyone to stay indoors. Only go out when there is a dire need. Do not play with anything electrical. Stay warm, stay safe. Thank you.